G'day everyone, and welcome to Lubrication Explained, where today we're going to be talking about the viscosity index, also known as VI. So what is viscosity index? Well, it's basically the measure of a lubricant's variation in viscosity over a temperature range. So like many fluids, oils change their viscosity with temperature. So if you think of honey, for example, you put honey in the fridge for a little while, it gets very thick and difficult to pour. If you put it over the stove and heat it up for a little bit, it becomes very kind of runny. Exactly the same thing happens with lubricants in service. As they cool down, they get very thick, and as they heat up, they get very thin. Unfortunately, this is the exact opposite of what we desire. So for a lubricating fluid in cold temperature scenarios, usually what we want is a thin fluid. So think of an engine starting up in cold temperatures. We want it to be thin because we want to minimize the amount of energy required to start. So think of the cold crank test. And we also want it to be thin because we want it to flow around the engine and get to all the components to make sure they're protected on startup. When things are hot, and when you're running at full load and full capacity, what you want is a thick fluid that has the capacity to hold as much load as possible and develop a strong lubricant film. So oil viscosity and temperature, if you can imagine for engine oils, for example, here's what it might look like for a 0W. So it decreases with temperature, and a 20. We can use viscosity modifiers to make an engine oil that sort of jumps between those two viscosity grades. Now, the industry standard is to measure the difference between a viscosity at 40 degrees and 100 degrees, and it's this dimensionless number which we talk about as being the viscosity index. Now, because it's a measure of the change between 40 and 100, you can have lubricants at different viscosities that have the same viscosity index. So in this case, the 0W and the 20 have the same VI, even though they are different viscosity grades, right? So it's the change between 40 and 100 that matters. Whereas the 0W20 has employed viscosity modifiers that enable it to have a higher VI between 40 and 100. Now, in actual fact, the viscosity and temperature curve is very rarely straight. In most lubricants, it actually looks something closer to this. One thing that you'll notice here is that particularly below 40 degrees, the relationship between temperature and viscosity is non-linear. And in fact, this has to be plotted on a logarithmic scale. So if you look at the y-axis, it jumps between 1, 10, 100, 1000. And you can see that at negative Celsius temperatures, viscosities get extremely high. So you can imagine engine startups in those circumstances can be very difficult. So what is, if you like, a good viscosity index? Well, going back to our table with all the groups of base oils, group 1 and 2 mineral base oils generally sit between 80 and 120. So that gives you an idea for their viscosity index. And the higher number here is better. So a higher number indicates a lower change between 40 and 100 degrees Celsius. Group 3s tend to be above 120, and in the synthetics with PAOs, they can sort of sit anywhere between 160, in some cases up to 200, 220. So that's one of the many advantages of going to a synthetic lubricant. Of course, the synthetics, for marketing purposes, can sometimes be a Group 3, so that's something to be wary of. And that's due to, of course, a 1999 legal decision. So, especially in passenger vehicles, the term synthetic is more of a marketing term rather than a description of how the product was made. So hopefully that's been helpful to explain the very simple concept of VI This has been Lubrication Explained.